Okay, so we start looking at sheet 14. This is about derivatives for trig functions, and then it opens up to derivatives of any other function. That is extended derivatives like the second derivative, third derivative, just like that. Okay, so question 1. Now before we look at question 1, there are these facts that we need to know. 1, the limit as x goes to 0 of sine x over x is equal to 0, and the limit is equal to 1. This is equal to 1, and then 2, the limit as x goes to 0 of cos x minus 1 over x is equal to 0. Okay, that's what we obtain. So these are just facts. We cannot start proving them in this course. We just use them. We can now go to question 1. Find the derivative of each of the following functions from first principle. A, the derivative of sine 2x. So you say the derivative of sine 2x, which you can denote by this prime, is equal to the limit as h goes to 0 by first principle of sine 2 x plus h minus sine 2x over h. This is the limit as h goes to 0 of sine 2x. I'm now expanding sine cos 2h plus cos 2x sine 2h minus sine 2x over h. Now, this is sine 2x, and this is sine 2x. This means that the sine 2x is appearing twice. So we can write this by factoring out sine 2x and remain with cos 2h here and remain with 1 here, minus 1 plus cos 2x sine 2h over h. Now, if I'm dealing with limits, remember, if you have the limit as x goes to 2 of 3x plus x squared, you can choose to write this as the limit as x goes to 2 of 3x plus the limit as x goes to 2 of x squared. You can as well take 3 outside and have that plus the limit as x goes to 2 x squared. You can do that because 3 there is a constant. What we mean by a constant is that it does not have any x in it. Okay. So using that concept there, we can separate. We have the limit as h goes to 0, sine 2x cos 2h minus 1 over h plus the limit as h goes to 0 cos 2x sine 2h over h. Now, h here is a variable that is going to 0. So sine 2x is actually a constant. So we can put it outside and remain in the limit as h goes to 0 cos 2h minus 1 over h plus we do the same to cos 2x and remain with this sine 2h over h. From there, if we look at what we have in the facts 1 and 2, the only thing missing is a 2 in the denominator, because for sine, this part here must be the same as this part there. Okay, so we need an xx, or since we have 2h, we must have a 2h down. The same with cos. So what we do is we multiply with 2 on top and with 2 down. So this is just the 1. You can cancel it if you want. You multiply with 2, you multiply with 2. Okay, you haven't changed anything. That is 2 over 2 is 1. Now the 2 that has entered inside, the 2 cos something, you can take that 2 outside because it's a constant and have the limit as h goes to 0 of cos 2h minus 1 over 2h. Okay, so you can do that. And then plus, again, that 2 there, you put it outside and remain in the limit as h goes to 0 of sine 2h over 2h. Now, the cos part goes to 0, becomes 0. So here we have 2 sine 2x multiplying 0 plus the other one 2 cos 2x multiplying 1, because the sine part goes to 1. And so the 0 part is just 0. Then we get 2 cos 2x like that. So that's how you obtain that. Okay. So that with the same style, you are going to have B as your task to try. So everything will go as this. Just be comparing. So you start, I start it for you. You have this prime is equal to the limit as h goes to 0 cos 3 x plus h minus cos 3x over h. Then you expand the cos. Remember, when you expand the cos, you have the limit as h goes to 0 cos 3x cos 3h minus sine 3x sine 3h. Then we have minus cos 3x and then over h. The first thing is you can see this cos here is that cos 3x there. So you factor it out just like we did on this step. So the steps will be the same until you get to the answer. So you finish up this one and convince yourself that you have understood. Okay. Okay, then you go to question 2. Differentiate with respect to x. A sine x plus cos x over sine x minus cos x. Now again here we need to have this very serious table. Before I even bring this question here, we have the following derivatives. Before I bring question 2, derivatives of trig. So the derivative, this is 1. The derivative of sine x is equal to cos x. You could do this using first principle because you've seen that for 3, it became the easy thing there. The derivative of cos x is equal to negative sine. The derivative of tan x is equal to, this is the same as the derivative of sine x over cos x. Now here use quotient rule, where you differentiate the numerator and you get cos x, multiply by the denominator, subtract, differentiate the denominator, you get negative sine x, multiply by the numerator, and divide by the square of the denominator. So on top there, you see that you have cos squared x plus sine squared x over cos squared x. But that is just 1 over cos squared x, which is equal to sec squared x. So what we are saying is the derivative of tan x is equal to sec squared x. Then the derivative for cosec x, that is the derivative of what? That's a derivative of 1 over sine x. Again, is equation true. You differentiate the first one, you get 0 multiplied by sine is still 0. Minus, you multiply sine, you differentiate sine, you get cos. So you differentiate sine, you get cos x, and divide by sine squared x. And this is the same as negative 1 over sine x. And cos x over sine x, which becomes negative cosec, and then cot x. So that's the derivative for cosec. It's cosec cot. Negative. The derivative for sec x, this is the dx of 1 over cos x. So you differentiate 1, you get 0. So the first component of quotient rule is 0. Minus, you differentiate cos, you get negative sine, so it remains as positive sine over cos squared x. This is the same as sine x. over cos x, 1 over cos x, which is again tan x sec x. So that is the derivative of this kind. The derivative of cot x, that is the derivative of cos x over sine x. You differentiate cos, you get negative sine, you multiply by sine, minus, you differentiate sine, you get cos, you multiply by cos, divide by sine squared x. You factor out negative, remain sine squared x plus cos squared x, divide by sine squared x. On top there, that's just 1 over sine squared x, and this turns out to be negative cosec squared x. That's the derivative of cot. So you have these main 6 derivatives here that you're going to move with. Okay? And so we will do this table when you look at integration, because that will just be the reverse of these. So you keep these 6 very careful. We can now go to question 2 and just apply the methods. Question 2a. You are differentiating sine x plus cos x over sine x minus cos x. So you let u be the numerator, sine x plus cos x, differentiate it. Derivative of sine x is cos x, derivative of cos x is minus sine x. Let v be your denominator, minus cos x. You differentiate, the derivative of sine x is cos x, derivative of cos x is negative sine x, then that negative there, you have sine x. So you're saying the derivative of this is going to be u prime, which is cos x, and minus sine x, multiplied by v, which is sine x, minus cos x, minus the denominator sine x minus cos x. Minus the derivative of v, which is v prime, cos x plus sine x, multiplied by u, which is sine x plus cos x. Everything we divide by sine x minus cos x squared. So if you try to expand on top there, we get cos squared x. Also, we get cos x sine x minus cos squared x minus sine squared x plus sine x cos x minus, we expand again, cos x sine x. So I've left the minus there because there's nothing positive inside, so everything will be minus. and then minus cos squared x minus sine squared x minus sine x cos x. Everything we divide by sine x minus cos x. This I think we'll need to square it. Sine x minus cos x. The way to square, I mean we need to expand. So let's see. This one and this one, they will add, but they'll be cancelling within. You can see this can cancel with that, and this can cancel with that. Okay, so we have remained with here we factored the negative. We factored negative for cos squared x, so that we have plus sine squared x. Again, we factored another negative for cos squared x plus sine squared x. And divide by, if you square it down here, we have sine x squared minus sine x cos x minus cos x sine x plus cos squared x. So here on top we have negative 1 minus 1 over sine squared x plus cos squared x. Again we have 1 minus these two are the same, so we can add them and we get sine x cos x. So this becomes negative 2 over 1 minus 2 sine. This is the same as sine 2x. So that's what we have as our derivative, 1 minus sine 2x. Because we chose to simplify, so that's why we have such a thing. Okay, go to B. B will have sine 3x plus 1 over cos 2x plus 3. Here again, we let u to be sine 3x plus 1. To find the derivative of u, you use chain rule. So if first differentiate sine, it will be cos 3x plus 1. Then you go inside and differentiate 3x plus 1, it will give us 3. So you have 3 cos 3x plus 1. Then you get v, it will be cos 2x plus 3. Then you differentiate v. Derivative of cos is negative sine 2x plus 3. Then you go inside and differentiate 2x plus 3. It gives 2. So that you have negative 2 sine 2x plus 3. Then you put them together now. So you're saying the derivative of this is equal to u prime, which is 3 cos 3x plus 1, multiplied by v, which is cos 2x plus 3, minus the derivative of v, which is minus also, 2 sine 2x plus 3, multiplied by u, which is sine 3x plus 1. Everything here we divide by the denominator squared, so I can put a square there. And so this, when simplified, it becomes 3 cos 3x plus 1 cos 2x plus 3 plus 2 sine 2x plus 3 sine 3x plus 1 over cos squared 2x plus 3. So that's what you obtain. You can't simplify further here. You just end there. Then for C, we are dealing with tan 4, 7x squared plus 3x plus 9. So here, you let u be 7x squared plus 3x plus 9. Then differentiate u. You will get 14x plus 3 using power rule. From there now, you come back and write this as tan u to the power 4. Then differentiate using chain rule. So the derivative here, the derivative is going to be 4. You drop 4 first and remain with tan u to the power 3. To the power 3, yes, because 4 minus 1 using chain, using power rule to the power 3 multiplied by the derivative of tan, which is sec squared u. Then we go inside again and differentiate u. So we need u prime here. So we substitute. We have 4 tan. I can now put the power here. What is u? U is 7x squared plus 3x plus 9 multiplied by sec squared u. U is 7x squared plus 3x plus 9 multiplied by u prime, which is 14x plus 3. If you have the energy, you can write this as 4 multiplied by 14x plus 3 and then tan 3 7x squared plus 3x plus 9 and then sec squared 7x squared plus 3x plus 9. That's how you differentiate such functions. So that was total chain rule. Now we go to D. I'm not leaving any here for you. Yours will be to revise after understanding. Cos 3, 5x. Okay. So here again, this is a product. So we use product rule, where we let u to be sine squared 2x. Now in here, this is the same as sine 2x squared. When you see the square there, it's the same as seeing it outside. Okay? Now to get the derivative of u, we first drop the power and we have sine 2x to the power 1, and then differentiate sine. It becomes cos 2x. Then differentiate 2x, we get 2. So 2 times 2, we have 4 sine 2x cos 2x. We go to v. Let v be cos 3, 5x. The same thing happens. We write this to cos 5x and take 3 outside. Then v prime will drop 3. We'll have cos 5x to the power 2, and then differentiate cos. It will be negative sine 5x. Then differentiate 5x. It will give us 5. So 5 times 3, we have 15 cos squared 5x, and the negative will come out, so that will remain sine 5x. So now the derivative of this is going to be u prime, which is 4 sine 2x cos 2x, that is u prime, multiplied by v cos 3 5x minus v prime. So say, okay, let me put this down. I want it to fit in one line. So it will be equal to u prime, which is 4 sine 2x cos 2x multiplied by v, which is cos 3 5x minus, now there's a minus here for v prime, so I'll just put a plus 15 cos squared 5x sine 5x multiplied by u, which is sine squared 2x. Oh, so I said here it was supposed to be plus because it's just product rule, so the minus stands there. So initially I thought it's quotient true. Okay. So we have that. So I'll finish the whole question 2 without any task for you. So tasks for you obviously will be in the next question. So we go to question 3. Question 3a, f of x is equal to e3 minus 4x. Now to differentiate the e function, you use a general one. Suppose y is equal to e to the power u. The derivative of y will be e to the power u. That is, if u is a variable on its own. Okay? But if u is a function, the derivative of y prime, of y, which is y prime, is going to be the derivative of u multiplied by e to the power u. So in this case, you let u to be 3 minus 4x, and then differentiate u, you get negative 4. So you are saying the derivative of f is going to be e of that is going to be u prime, which is negative 4, eu, which is e3 minus 4x. And so that is negative 4e3 minus 4x. So this one is always an easy thing. Just differentiate the power for the exponential and then multiply by the whole function. So let's see. B, f of x is equal to sine x plus cos 2x. What's your thought? Oh, I've left out e. So there's e here. What's your thought? I guess you're thinking about the numerator here being sine x plus cos 2x. So you let it to be a u. So you say this is sine x plus cos 2x. And then what's the derivative? Derivative of sine, cos. Derivative of cos, negative what? Negative sine. Then you also differentiate the 2x, so you start with 2, and then sine 2x. So the derivative of f, we just put things together. It will be u prime, which is cos x, minus 2 sine 2x, multiplied by e sine x plus cos 2x. That's all. So the E case is the easiest case to deal with. What about C? C, okay, so for C, we have f of t is equal to e to the power t, and then sine squared cos t. So this is product rule, where you say your u is e power t, and so it's easy to get the derivative. U prime is just et because the derivative of t is 1. And then v is sine cos t squared. So sine is the holding function. So first we drop the 2 when looking for v prime. We drop the 2, we remain with the sine cos t multiplied by, we differentiate sine, so we get cos t, and then multiplied by, we differentiate cos, so we get negative sine t. So everything becomes, for v prime, it becomes negative 2 sine t. The sine t in front comes out, and then sine cos t, and then cos t. So then done squaring, because you cannot square an angle which is inside. So cos t there is an angle inside. So you can't say cos t is cos squared. No. That is cos t. So now what is f prime of t? So f prime of t is u prime, which is 18, multiplied by v, which is just the whole function, cos t, plus, now there's a minus on the v prime, so we'll have minus this, so just say 280, and then sine t, sine cos t, cos t. So this becomes the derivative there. Okay. Okay, so let's look at D. What about D? F of u is given as cos e to the power 3u. Okay, so you let v be e to the power 3u. The inside angle, what will be its derivative? So the derivative there will be 3e 3u. Just differentiate 3u, then multiply it by the e to the power 3. So that your f prime of u becomes the derivative of cos. First thing, because here is in chain rule. The derivative of cos is negative sine, and fix the whole thing inside. Then multiply by its derivative, which is 3e 3u. So you can write this as negative 3e 3u sine E 3u. That's a derivative there using chain rule. Now let's do the interesting one, f. So f, we were dealing with f of x is equal to 2 to the power x squared multiplied by 5 to the power x minus 1. So this is product rule. So first let u to be 2x squared and then differentiate u. Now differentiate u is not that easy. You don't just go straight and say the power and the what, because the e there, I mean the base is not e. The base is something else. So when it was e, it was easy just going direct. Okay. So because it's not e, excuse. Okay. So because it's not e, what do you do? You say, okay, let, do you even need to let? No. Just apply the ln u on the left, ln 2x squared also on the right. And then the ln, you know, it has the property of dropping the power. So you have ln u is equal to x squared ln 2. Okay. Then now you differentiate using implicit differentiation, where you are differentiating u with respect to x, but u is standing alone on the left, but inside the function. And remember we said that the derivative of x, the derivative with respect to x of ln x was 1 over x. Don't forget that. So here you say, to differentiate ln u, we'll say 1 over u multiplied by what? Multiplied by du dx. This is to show that u was actually a function of x, as you can see here. And then we differentiate on the right with respect to x. So x squared will give us 2x. And then ln 2 is just a constant. Now we are looking for du dx. So you can cross multiply. We multiply by u over 1. We also multiply by u over 1. So that we have du dx is equal to 2x ln 2 multiplied by u. But what is u? U is 2 to the power x squared. So that's the derivative of u. Again, let v be 5x minus 1. Apply ln. It will be ln v is equal to ln 5x minus 1. Then you drop the x minus 1. So you have ln v is equal to x minus 1 multiplied by ln 5. Then you differentiate again with respect to x. So on the left, we have 1 over v multiplied by dv dx. And the derivative of x minus 1 is just 1. So here we just have ln 5. As usual, we multiply by v, we multiply by v. So dv dx is going to be v, and v is what? V is 5x minus 1 multiplied by ln 5. So now this was product rule, so we put things together. So we're saying f prime of x is going to be u prime. So it will be u prime v plus v prime u. But what is u prime? U prime is what we have here. So that is 2x ln 2 to the power x squared. This whole thing we multiply by v, and v is 5x minus 1 plus the derivative of v, which is 5x minus 1 ln 5 multiplied by u, and u is 2x squared. So this is the derivative of what we are looking for, which if you want, you could factor out. You could say, you can see there's a 2 power x squared, there's a 5x1, there's a 5x1, there's a 2 power x squared. So you could as well factor out that and say, okay, I have 2x squared multiplied by 5x minus 1, and then you factor out inside we have 2x ln 2 plus ln 5. So you do that if you want. You're not forced. It's your decision to make there. So you can easily do that. Okay. So we go to question 4. What's there on question 4? Question 4, use implicit for the following functions to find dy dx. So A, we have y plus xy plus y squared is equal to 2. We did something like this. Now to find dy dx here, you first differentiate y with respect to itself. So it will be 1. Then multiplied by dy dx. So it will be dy dx plus, use product rule here. Differentiate x first, you get 1. When you differentiate x, you get y. xy with respect to x, you get y first, its coefficient. Plus, differentiate y, you get x. Okay, this very y here, x becomes a constant. And then, since you differentiated x, you multiply by, since you differentiated y, you multiply by dy dx. And then differentiate y squared, it will be 2y. But because it is y, is equal to 0. So that you factor out dy dx, and then you get 1 plus x plus 2y is equal to negative y, when this y has been taken the other side. So you're looking for dy dx. So it will be negative y over 1 plus x plus 2y. Like that. Okay, so here you have a task. You do 2. You do B the same way we did A. So C is x is equal to y e to the power x. Now they're saying use implicit. Otherwise, you could solve for y here. So to use implicit, we'll differentiate x, it will give us 1. We'll differentiate y, we'll get e to the power x. But because it is y, we'll have dy dx. Plus, because this one was product rule, we differentiate e to the power x, we'll just get e to the power x, because the derivative of x is just 1. So we're looking for dy dx. So we have 1 minus y ex is equal to ex dy dx. You can divide by ex, you divide by ex, so you remain with dy dx is equal to 1 minus y dx over ex, like that. And that's how you obtain the derivative of that one. Okay, what about d? So d, 1 over x squared plus 1 over y squared is equal to 1 over 4. You can write this as x negative 2 plus y negative 2 is equal to 1 over 4. Then differentiate throughout. So for the first one, you get negative 2x Separate the 1 from the power, -3. Minus 2y minus 3, but because it is y, you have dy dx. This is equal to 0. So dy dx will actually be 2x -3 over -2y -3. And you can write this as my dy dx is equal to, on top there we have 2 over x3. And down here we have -2 over y -3. I mean over y3. Because I've taken down those parts so they can no longer be negatives. So this means that we have 2 over x3 multiplied by y3 over -2. So that one, this one, so we have negative y3 over x3. We do that. Others would want to write it as negative y over x to the power 3. It's the same thing. That's how you get your dy dx. And so you go on. E, that is sine x cos y is equal to 2. Using product rule on the left, you differentiate sine x, because here you are letting u to be sine x. Its derivative is cos x. Then you let v to be cos y. Its derivative is negative sine y and dy dx. So from there, we have u prime, which is cos x multiplied by v, plus, and then there's a minus. So we'll have minus sine x sine y and dy dx is equal to 0. So we take, so we have cos x cos y is equal to sine x sine y dy and dx. So we divide, we also divide. So this and that cancels. So you have dy dx is equal to cos x cos y over sine x sine y, like that. So I hope you learned the skill here and you're able to do F. So you're using product rule for x and ay. So when you differentiate ay, it will be ay multiplied by dy dx. That will be the only difference. Everything else will be okay. Okay, so we have done question 1, 2, 3, 4. Oops, this is a long one. So the next class will be on 5, 6, 7, 8, 9. Yes. They are too long, I think. Yes, I'll end here.